towards deployment mode, I think we want to change our focus a little bit, and we wanted to kind of give you a brief overview of, number one, some great ideas for deploying LTE and how to optimize LTE, and also some of the challenges that you see with coexisting 3G and 4G networks. So, slide 2. All right. So if you take a look at the fundamentals of optimization in an efficient wireless network, it really starts with the transmission system, obviously integrating the eNode B, making sure that your spectrum is clear in case you have new spectrum or maybe you're migrating from a 3G technology. And then lastly, your system configuration. So after you've integrated your network, then you've got a chance to go out and validate all the blocking and tackling, such as device performance, eNode B performance, things like SON, all of those things that matter to the customer. Those are the things that you can review in system config. Slide 3. So this slide kind of gives you a very basic overview of the process, right? And think of it as a short-term and a long-term process. So during the integration phase, obviously that's a short-term implementation. That's when you're going to be using test equipment such as BTS simulator. You're going to be doing a lot of VisWAR and PIM spectrum analysis, all of that blocking and tackling to try and integrate your 4G network. And then we talked a little bit about system config, and again, that's validating your system, handoffs, SON, customer perceived throughput, loading, all of those things come into kind of a longer-term system config. But really, what we want to do is we want to step back and take a look at, do we use this measurement equipment just for a short-term play, or do we leverage it for a longer-term play? So next slide. So some of the key issues that you commonly find with test equipment, number one that comes up are, very buggy platform, new releases. Whenever you have those new releases, there's obviously a lot of complexity, a lot of features that really don't make sense. There's also standardization, such as chipset support, and then making sure that all of your devices and obviously your infrastructure tries to converge to meet that standardization for 3GPP, and we'll talk about that a little bit more in a minute. And then support. Obviously, whenever you're launching a new 4G network, LTE network, one of the things that you're going to want is rapid support on all these tools and the overall process in general. And then lastly is cost, right? So how much budget do we have? Obviously, we're investing a lot of money into deploying a new technology. So how much budget do you have left over to purchase test equipment? So next slide. So the next section, we're going to go into field measurement data versus network collected data, and we're going to talk about that in more detail here in a minute. So for those of you who've been around in the industry for quite a while, you remember the older platforms were very basic, right? RSSI measurements, you go out to the field, collect data, do your own post-processing. It was very, very basic, and there wasn't a lot of tools to support it. So then you move into 2G and 3G deployments. You're deploying new networks. There's a lot of greenfield, a lot of new spectrum that's been purchased, new companies emerging. So during this time, you're starting to see more intelligent switch metrics, and you're also starting to see a very aggressive competitive market for field measurement test platforms. And then you fast forward to 3 or 4 years ago, and you see that same evolution, and you also see more complexity, right? So you're seeing broadband drive test platforms that support multiple frequencies, multiple bands, multiple technologies. You also see more intelligent geocoded network data being leveraged by all the vendors so that you can compile them in a local database. So you can see that there's two distinct roadmaps. There's what you collect in the field empirically through your field staff, and then there's also the data that you can collect centrally, so you can try and centralize performance and get a better idea of the metrics. So next slide. So the key question is what's the relevance of field testing as we fast forward to 2011, 2012? What's the real relevance of collecting data in the field? Obviously, there's a need once you integrate a network, but again, longer-term strategy is there's still a distinct need for field testing, right? So before we can answer that, we're going to take a look at both network collected data and field data. So on this slide, we're going to overview some pros and cons of centralized or network collected field data. And the key question is can you leverage everything that you collect in the network to basically overcome any kind of field collected data, right? And for the most part, there's significant value in network collected data. You can do analytics on a large scale. Obviously, the OpEx savings that you have by not deploying personnel out to the field. And then it's on demand. So 24/7, whatever time frame that you desire, all of that's rapidly available if you use network collected data. Obviously, some of the cons, there's a lot of work that goes into that. There's a lot of servers, a lot of databases, data corruption issues, network licensing, and more importantly, the customer perception of any kind of eavesdropping. So if you're logging devices that belong to your customer, at what point does that not cause issues, right? So those are some of the things that you look at for network collected data. Next slide. So drive test data. The nice thing about drive test data is that you have control. There's distinct control in the entire process. So when you want to drive, where you want to collect, whether it's in building, street level, however you want to set up your test platform or your test cases, you have full control of that. And obviously, with drive test platforms, you have the availability of having a scanner. And scanner obviously is a huge benefit because it shows you not only what's going on within your own network, but it shows you externally as well. So if you're troubleshooting interference issues or maybe taking a look at competitive technologies next to your spectrum, that's where scanner comes into play. And furthermore, you can really do in-depth device analysis. So as you start to get new devices or different chipsets that support different technologies at different band classes, if you need to test that and leverage what your customer is seeing, this is basically your only opportunity to do that through drive testing. And then again, some deeper analytics with layer 3 and interference. We talked about that. But the cons, very expensive, it's time consuming, and a lot of the feedback from the field teams is it's very complex setup and post-processing. You've got different platforms to deal with and maybe 2 or 3 different drive test vendors, so all of that kind of adds up. Next slide. So new technology risk. Anytime you deploy new technology, even though you have a standard, in this case 3GPP, obviously the standard lays out what you're supposed to do, how you're supposed to do it. But it doesn't really talk about or manage some of the details for scheduler, for example, or maybe layer 3 messaging support, device performance, if the device can support various LTE channel size. All those things come into play, right? And so the only way testing, take that data and make sure you work with your vendors to establish that process. Next slide. So what's the punchline, right? Which one's better? Is it network collected data or is it field measured data? And basically the answer is they complement each other. I don't think you could leverage one without having the other because each has its own distinct benefits. But for this slide, we want to show a couple of technical examples of field measurement and why that's beneficial. So in the spirit of new LTE networks, and as you deploy 4G overlays over an existing 3G network, I'm going to talk about two key areas. And one of them is an empirical example of a 4G to 3G handoff and what the customer experience is. And then also, we're going to talk about link budget. And we're going to talk about why link budgets are so important and how to leverage field measurement in order to successfully plan. All right. So in the following slides, basically what you're going to see is an example of an LTE rollout. And as you typically roll out LTE, typically you don't do a one-for-one throughout the entire existing coverage footprint. Usually you roll out a new technology in phases, right? So in those boundary areas, you're sure to have customers, different usage patterns, different usage trends. So how can you leverage field measurement data in order to capture the customer experience, right? Some carriers, in the event of a 4G or an LTE to 3G handoff, a lot of carriers will elect to deploy EHRPD, and sometimes you don't necessarily have to. So in that event, again, how do you quantify the customer experience and communicate that back to the decision makers? Next slide. So in this testing that you're about to see, again, it's an LTE to EVDO handoff. It was a continuously streamed high-definition YouTube video. It was tested on a commercial LTE network, and you can distinctly see the 4G to 3G border. So one of the very first things that you want to do is identify where the LTE cell edge is, right? And this is a very clear example. To the west, you can obviously see where you have LTE coverage. And then heading out to the east, you can see where LTE absolutely dies off. And again, it's a bidirectional test. And starting from square one, pretending like you know nothing about the handoff mechanism between LTE and a 3G or EVDO network. Again, you want to try and assess what the coverage areas look like, what the handoff zones look like. And in order to do that, you need the tools that allow you to clearly see. So in this case, again, you can see where the 3G coverage area is, and then you can see where the LTE carrier is. Next slide. So looking at it on the time domain, basically you can correlate RF performance, so you can see the distinct degradation in RF performance and where that handoff takes place. And more importantly, you can see where that connection was maintained, and you can see the throughput differences between LTE and EVDO in this case. And then again, taking a look at RSSI versus signal-to-noise ratio, and looking at on a per bin or per timestamp basis. Next slide. So one of the advantages of having a tool that can collect both 3G and 4G is that you can take a look at each bin and again correlate that geographically to what the performance looked like. And in this case, that's what we're looking at. Next slide. So in order to truly validate that handoff in the event that it took place, you always look to layer 3 messaging, and you try and validate where that handoff took place, what the messaging looks like. Do you have any ping-ponging? Are you seeing multiple occurrences of the messaging? And that's what we're looking at here. And in this case, you can clearly see the handoff from LTE to EVDO. Next slide. So what does that mean? What does that mean to the customer? If you're a customer and you know nothing about LTE to EVDO handoffs, what's your experience? So as you're watching a YouTube video, what do you see or what do you experience during that time? And in this case, there was buffering that took place, so you noticed no hiccups whatsoever during the testing. And I think obviously a follow-up that you would want to do in your testing process would be to look at unbuffered or real-time applications that would clearly show any kind of degradation during that handoff process. But in this case, really that handoff process took 24 seconds. So in a real-time application, what does that mean to the customer? Next slide. All right. Link budget. Next slide. When we talk about link budget, if you think back about 5 or 6 years ago, link budgets were pretty boring. You had a 3G technology. You knew your gains and your losses, your margins. Link budgets were very easy. They didn't change. But if you think about where we're at today, there's always momentum on getting new spectrum. There's different devices, different technologies, different applications, different ways to deploy technology, such as remote radio head versus standard macro deployment. All of these things really decide your strategy and how you compete against some of the other wireless carriers in any given network. Right? And a good example of this is if a management team asks you, what would be the difference between 3 megahertz, 5 megahertz, or 10 megahertz LTE deployment? 700 megahertz PCS or AWS, and what would those cell edge bit rates look like? So what would be your cell radius based at 64K, 128K, 512K? What does that mean to coverage and customer service? Right? So you're seeing link budgets become a lot more complex, especially when you co-locate or coexist with another technology. And you're going to see more of that on the next slide. So what you see here is the risk that any wireless carrier that would have when you're deploying multiple technologies, multiple device types, is that if you're a customer and you have a smartphone and then you decide to buy a 4G broadband card, what would be your customer experience at any given point, whether that's cell edge or close to the cell? As a customer, you're not going to know, right? But the biggest risk is that your customer is going to have a significantly different experience. So understanding this before you deploy the technology is paramount. But more than that, having a model on paper, you need to be able to calibrate that to empirical field data. And that's the importance of collecting field measurement data to validate your link budget. Next slide. So if you miss, if at a very high level you miss some of your link budget estimations, what does it cost you? What does it cost the customer or the company? And this is kind of an eye chart, but up at the top you have some very basic assumptions based on CapEx and OpEx spend, right? And again, these are very basic. So let's say you have a market with 100 sites, and you're off by 5%. There's a 5% difference between your 4G coverage footprint and your 3G coverage footprint. What would be the total spend in order to balance those footprints, right? So this is a very basic model showing coverage deltas from 5 to 25%, and based on a very basic linear scale, on 100 sites, if you miss 5% of your coverage, you're going to need an incremental 5 sites. So based on the capital spend for that, you can see that that's $1.2 million, right? So in order to compound that and take a look at that on a larger scale, if you have a 400 site market, or let's say you have a 1,000 site market, again, if you take a look at those coverage deltas, you can see your capital investment stacks up pretty quick. And not only your capital investment stacks up, but also your operational investment will stack up per year. So again, you can see that proper planning for your technology, even before you make the decision, is paramount. And that's why, you know, calibrated link budgets by using field data is so important. Next slide. So you might ask, what do you do in the process, right? You know, obviously it's not simple, because ideally you would want to do it in a trial environment. For the most part, wireless carriers have a lot of customers at all times, and it's hard to try and baseline a network. But it's not impossible, and I think, you know, the importance of this task certainly warrants you know, calibrated link budgets. So ideally, you want to have an isolated, you know, 3G and 4G sector. You want to be able to collect a lot of data, and you want to be able to clearly define or determine where the sellage is. And in a link budget, for the most part, you always look at uplink, because uplink is the weak link, but you always need to have a link budget for both uplink and downlink. Gives you a good idea of number one, the true coverage deltas between uplink and downlink, but it also gives you that much more data to calibrate from. So while you're conducting your tests, obviously you don't want any loading, backhaul congestion, or limitations, handoff issues, none of that stuff. You want a totally isolated sector. And again, log uplink and downlink throughput, all of your data frame or packet error rates, and then obviously device transmit power to see what's going on the uplink. And during the same time, you can also log at the base station if applicable. So you can log per call uplink RF measurements. So ideally what you want to do is you want to post-process and see what you calculated in your link budget as far as cell radius or cell coverage area. You want to see if that matches up to what you're seeing for that morphology. So if you have suburban or rural or urban, you want to be able to calibrate based on where you did that drive test and see if your pay-per-link model is within, you know, 5 or 10% of what your link budget should. And then, more importantly, you know, it's a common thought to say, well, if you have a 1.25 3G channel versus a 5 or a 10 or 15 or 20 megahertz LTE channel, of course your throughput's going to be different. Of course your link budget's going to be different. But one of the things that you can do, and it's very simple, is to normalize based on spectral efficiency. So in essence, you could create a link budget based on you know, bits per second per hertz over distance. So it's just another thing that you can do to validate that your 4G technology is that much more efficient for the given amount of bandwidth. Next slide. All right, next slide. So we want to summarize again what the risk is, what the clear message is, and what we're looking at. New devices, new applications. You've got cloud technologies. You're probably going to have another phenomenon like Angry Birds, or obviously the continuing emergence of video applications and, you know, social networking. All of that is going to change over the next couple of years. In order to understand what the usage patterns are and how that affects your network, you're going to have to be able to go out and empirically test this in the field. Then you have new technologies, new 3GPP, roadmap items like voice over LTE, LTE advanced with carrier aggregation, small cell technology. How do you implement small cell with a larger macro network? All of those things will be very important to understand and quantify before you make that decision to deploy to your customer. And the way to do that, again, is through very effective field measurement testing. So that's it. I think we can open it up now for Q&A.
Thank you so much. So we are now moving on to the Q&A session. And we have a couple of questions here. I will read them, and Emilio and Ron will answer them. And here is the first one. What is EHRPD? And this was submitted by Mike Miguel.
Yeah, EHRPD is a mechanism in order to facilitate the handoff between a 4G network and a 3G network. So it's a core implemented system, so that transition is more seamless instead of a make or break.
Okay, thank you. And then the next question is by Doran Penetopol. Sorry, Doran, if I chopped up your name like there, but which is the minimum LTE SNR for which the UE can decode a signal?
Hey, Doran, I know per the 3GPP specs, they actually use EVM. So for 64 QAM, you're looking at 8% EVM. For 16 QAM, it's 12.5%, and for QPSK, it's 17.5%. So again, it's going to vary, but it definitely is on the signal noise ratio, but it's actually based on the EVM measurement.
Okay, and then Doreen had a follow-up question to that. Can you please give an example when QPSK or QAM is being used?
QPSK, well, there are a few control channels, like the physical broadcast channel. It's always in transmit diversity, and it's always transmitting QPSK. QPSK is also, again, it usually goes with transmit diversity, and it's also used for coverage at the cell edge. So the idea is to have better performance at the cell edge of LTEs and QPSK.
Yeah, and it's really dictated by your modulation, by your MCS selection, right?
And then QAM, usually you're going to get that as you get closer to a cell site. You have, again, your signal noise ratio, your EVM. Especially if you're stationary, then you're more than likely to get around the 64 QAM.
Okay. This one is by Frank Zhu. What's the typical LTE cell radius you see in the field, and what are carrier frequencies?
So it really depends on what channel size that you're deploying, whether or not you're using remote radio head or not remote radio head. But as a general rule of thumb, you're probably going to have about 5% less coverage than your existing 3G network. But again, that could change if you put a remote radio head up or if you use more power, wider channel size. A lot of that's variable. But what you're seeing for the most part, same band. Again, strictly same band. You will see that 3G technologies in their link budgets always outperform LTE.
And as far as the bands, they really are all over the place. I think we have up to 41 or 3 bands right now. In the U.S., it's typically going to be the 700 in the AWS, though I can see this going to 800, 1900 eventually. In Europe, you're looking at 2.6, and what they use 800, which is their television band. In reality, they're all over the place: 2.6 gig, 2.5 gig, and basically all the current bands that are out there. And usually, in some regions, though, they are limited by their governmental offices determining which bands are actually used for LTE.
Okay. And then we have, what Anritsu equipment can be used to collect LTE and UMTS field data?
For drive tests, we do have a product called LinkMaster, and we have two products actually. The LinkMaster LML is for collecting, and LMA is the post-processing tool. So we do have that for 2G, 3G, and LTE.
Okay. And then this kind of analysis is valid for Wi-Fi metro networks?
We do have some Wi-Fi capabilities that we've added to our LinkMaster because of the, I guess with the use of the smartphones, there are a lot of carriers are offloading data to Wi-Fi, so we've added that measurement capability to our LinkMaster product. So yes, you can use that. I'm not sure how everybody else does that, but obviously there's a major portion now of the carrier strategy for offloading data.
Okay, thank you. And what is the importance of scheduling algorithms in the performance of an LTE network? And also, how do you test the performance of a scheduler?
That's a great question. So different OEMs will have different scheduler releases that really right now what we're saying is that you can have really good per user throughput, but when you start adding loading, the scheduler could not really degrade, but it might favor a single user throughput versus multiple users, right? And then you can have the inverse. You could have one vendor that could obviously favor handling capacity versus peak single user throughput. So you're seeing changes like that in the scheduler that create more efficiencies and make a better user experience based on capacity or single users. Now, moving forward, with voice over LTE, scheduler is going to be paramount because scheduler algorithms are going to dictate the amount of users that you can get in for a given amount of spectrum and the quality of service that you have. So scheduler is the actual secret sauce behind everything in LTE. And what you're seeing now is that continuing evolution in that tweaking and fine-tuning of scheduler releases.
Great. And then just a couple more questions because we're running out of time. What is the typical reverse link receive level does the eNode B like to see?
Well, I'm not sure that you could really quantify that on a per user basis. Obviously, there's the noise rise component for an eNode B. And you know what? I don't have that data.
And I think it's also going to vary depending on the bandwidth of the carrier too.
The carrier. Yeah.
So typically, the wider the bandwidth, the lower, well, actually the higher. But to be honest, I don't have exact numbers for that, like Ron mentioned.
Okay, and then why is LTE coverage lesser by around 5% compared to 3G, as just mentioned by the presenter?
I think if you take a look at the overall efficiency, when you log throughput over distance, and again you start throwing components like maybe 25% loading or 50% loading, when you look at all those variables, one of the things that you'll see is we'll start with 3G voice, right? 3G voice is extremely robust from a link budget perspective. Anytime you start to have higher data rate technologies, they're a lot more sensitive when it comes down to quality of service. So in order to meet that quality of service metric, you either overcome it with power or obviously wider channels, better RADs, or better line of sight. All of those key components come into it. But typically, again, if you take your link budget that you have for LTE and you plug in the interference margins, signal noise ratios that come from the vendor that are modeled, you plug those in, and then obviously some of the carrier power values, the losses, gains. you'll clearly see that 3G always usually has a better link budget. And when I say 3G, I'm really comparing it to voice. If you take a look at EVDO or let's say maybe UMTS, pure data technology, the link budgets are a lot closer. There's a convergence. But if you try and compare data to voice, you'll see that that voice is always usually far more superior.
Okay, and then this is going to be our last question. How important is RSRQ in analyzing and troubleshooting issues in the network? Can you give a few examples of how RSRQ from field data is used?
Yeah, I mean, RSRQ and RSRP, I mean, you're going to leverage both of those metrics in order to, again, typically using some kind of demodulated power format as an indicator. So in the EVDO case, or CDMA EC versus EC over I naught, right? That's a demodulated metric over total power, total noise. So using those metrics, just as you would in any kind of 3G technology, you basically leverage those in the same fashion to determine, what's your total interference based on certain loading conditions, or again, adjacent channel interference, depending if you have IC implemented or some kind of interference cancellation at cell edge. So again, it goes back to the typical blocking and tackling that you would use in a 3G sense.
Okay, and that wraps up our Q&A session. I'd like to thank everyone so much for attending. It was a great webinar, and I'd like to thank our speakers, Ron and Emilio, and I will be following up with everyone. I'll send out an email with some slides and the archived version of the webinar, so please feel free to spread it around and share with your colleagues. And thanks again. If you have any questions, please feel free to email me. My name is Sandra Kuya, and I am with RCR Wireless. My email is skuya, CUY as in Yahoo A, at rcrwireless.com. And thanks again, and have a great day.